Okay, let me start. Today's student lecture presenter Yuan. And today's topic is ocean plant and design. I will give you information very quickly. Maybe you need supplementary explanation from professor. Okay, and this is today's contents. First, I'll talk to you about the offshore installations and kind of plants for oil and gas excavation. And then I'm going to explain some few examples about the other offshore installations. This image is a very brief image for the deepwater field layout. There are many structures over this picture. First, you can find the subsea drilling systems, which is drilling structures for the wells. The well is for the oil and gas excavation. Simply, it is a hole under the ground. So after you drill the surface of the ground, it becomes a well. And then there is a subsea trees. The tree means a structure over the well or the flow line. It covers the hole and connects to the flow line for the oil and gas transportation. The smart well system are kind of controlling system for the well. And there are some manifolds and subsea processing. The manifold is the gathering site for the oil and gas. And subsea processing is kind of post-processing structure for the oil and gas. From this processing part, you can control the pressure of the oil or gas and can mixture with some water or some kind of chemicals for the post-processing. And this ship is filling the tanks with processed oil or gas. And this table is for the supply chain of offshore oil and gas. Under the ground, under the ocean, we can get oil, gas, or energy, which is ETC. This table shows the brief process of the oil and gas excavation. First, with drilling rigs or drilling ships, we can make a hole. Then with the well, with a tree or some subsea processing structures, you need to be pre-process the oil and gas with the subsea systems. And the production and storage, it means post-processing and storage system for each oil or gas. Then transport system can transport the oil and gas, the tanker or pipeline or LNGC. Then it's supplied to customers. With the terminals are quite very hard to understand. These are the explanation of the terminals. First, FLNG is floating LNG production unit or plant. It can be a ship or some fixed plant, but FLNG means all of that. And VLCC is a very large crude carrier, and this is the very big ship or the crude carrying. And URF is umbilical and riser and flow line. The umbilical means some kind of a multi-purpose hose or cables, excluding the flow line. And riser is the flow line or production line connected to the surface. So basically, this line can be a riser because it's connected to the surface. And the flow line is quite similar to production line, but quite different for the purpose. And FPSO is floating production storage and offloading ships, kind of ships. And FSRU is similar to FPSO, but it has the regasification unit. So floating storage and regasification unit is FSRU, and LNGC is simply LNG carrier. This is the video for LNG.
with periodic offloading of the LNG product to shuttle tankers. With a solid track record in the design and delivery of FPSOs, LNG and subsea, Technip FMC proposes a full range of services from the early concept definition phase through to engineering and execution. As a world leader in subsea projects, Technip FMC, including according to wind, waves, and currents. Optimum process and designs all the topside modules to receive the gas on deck. NGL is also removed with co-production. The FLNG is designed to store a large quantity of LNG plus condensate and LPG as required.
Okay, I'll bring a simple solution for the drilling units. There are a few ways, some semi-submersible or jackup or drill ship solutions. So those are quite different. First, a semi-submersible is basically a floating lens for the drilling. Like this image, it is floating over the surface and fixed with underground to not flow away. But the drill ship is basically it shapes like a ship and it drills with the drill placed in the underground ship. The jackup is quite hard to understand, but it is quite similar to semi-submersible, but different because it has legs connected in the ground of the surface, the ground of the connected with the ground. So this video explains the jackup structure very briefly. This is connect the leg with the ground and loop with the leg with the ground. But semi-submersible do not have legs, so it controls the height with the ballasting system, which controls the specific weight of the structure, so it can control the how deep is the surface thickness depth. I'm not sure about this question. Okay, and then this is the example of the one of the biggest plant for the oil and gas excavation. The name is Troll A in Norway. The structure is placed in the North Sea of the Norway and the Troll gas field. This structure is kind of very high and tall structure. With the right image, you can see that it is even higher than the Eiffel Tower. The height is about 472 meters, and in normal shape, the actual height is like this, and the under the water, the height under the water is about 303 meters. And it can be called as one of the most complex and biggest structure of the world. This is a sample image for FPSO and LNGC. As I said, FPSO is floating production, storage, and offloading unit. So the blue one is FPSO. It is connected with the underground, subsea plant system, and it produces and post-process the oil and gas and liquefy the gas to LNG, and it offload to LNG carrier. Then this LNGC carry the LNG tanks to the ground. And this is FSRU and regasification unit image. basically FSRU is simple, quite similar to FPSO, but it has a big difference because it has regasification unit, which is before the actual use of the gas, we have to regasify the LNG because it is a liquid. But many people hate to install the regasification plant because it's quite noisy or some air pollution. So many producers choose the floating plant, and this is yes FSRU. So near the land is FSRU ships regasify the gas and transport the gas to the land. This is the image of the regasification unit, but I'm not familiar with this. Okay, next is other offshore installations. This is the image, sample image rendering about the mobile harbor. Basically, this mobile harbor system is developed in KAIST. And the main purpose is with some small harbors, it cannot be, you cannot dock a big container ships, such as the evergreen ships. So with the mobile harbor, the ship is quite far from the harbor, but this mobile harbor can move to the ships and offload the containers. So with the small harbors, we can offload the containers from the big container ships. This is MIT's offshore floating nuclear power plant. As you see, our professor explained very simply before, I think 2 weeks ago. This idea was actually presented in 2014, and this idea's key purpose is for the withstand of the earthquake and tsunami. I think this is because of the Fukushima nuclear plant accident. It is at 2011. I think maybe they want to develop this system because of the Fukushima incident. Yeah, basically it is floating, so we can withstand the earthquake, and it can be freely moved. So with the tsunami, it can jump over the tsunami, maybe, I think. And lastly, there is wind turbines. Maybe you have saw this before. Currently, the land-based wind turbines are very basic, but it is quite noisy, and there are not many sites for the installation. And the ocean bottom fixed wind turbines can be used at the shallow ocean, but still it has limited size. So the final version is the floating version of the wind turbines, but still it has some limitation about the technology or extreme cases. So maybe we can discuss about this later. And this is my last video. No. I found it from the internet, our professor's investigation group. Very short video. Professor Han's group made this.
Hey, you want to get leaner, stronger, learn some cool calisthenics, body weight skills, but
With the pipe, it can hold the planar position. Yep. Okay. With the specification, we can discuss it later. And this is for today's student lecture. I prepared. The lecture is, my lecture ends here. Thank you. If you have a question, please, or we can discuss it later. If Sunyu leads discussion session. Thank you.
Very much. See, next time you should raise a question when the other student has a question. Okay? Thank
Yes, sir.
you can do by online.
Yes, I prepare presentation. Please share the screen.
You can be the host. You can share your screen.
Okay.
위에 디스플레이 설정에서 네.
자, 그럼 시작하겠습니다. Hello, I'm Lee Seung-gyu. Before we start the discussion, I want to ask you something because I got coronavirus, so please understand my voice condition is bad, and please speaker speak English slowly because it is quite hard to understand because I can look speaker you speaking. Okay, I prepared two topics, so I will start discussion. Thank you. The first topic is can offshore nuclear power plant be widely commercialized? Have you ever heard about academic Lomonosov? It is the first floating nuclear power plant in the world. It began operation in December 2019. The generation capacity is 70 megawatts. It is very small size comparing nuclear plant onshore. For example, Korean nuclear plant module AP1400 have a capacity 1,400 megawatts. So it is just 5% capacity comparing a nuclear power plant of land. And Mr. Han introduced us OFMP before. MIT present offshore floating nuclear power plant in 2014 and 15. They said it is more affordable and safer, and there are so many advantages to make to install offshore floating nuclear power plant. So I want to discuss about this. So can floating or underwater nuclear power plant be widely commercialized? So I want to listen your opinion about advantage or disadvantage or expected problem, and what we do need to overcome the limitations. So anybody have an opinion?
Okay, just keep going.
Maybe it's easier to cool down the temperature because it's in the
Should
ocean.
you make your name first? Pronounce your name first.
I am Yasin Serouchni. For me, one advantage maybe it's easier to cool down the temperature of the warplanes because it's in the ocean.
Sorry, I couldn't listen you well. So please speaker can come forward to speak the opinion.
Can you hear me now?
Thank you.
You can hear me? Well,
Yeah, well,
okay. I'm Yasin Serouchni. For me, one advantage may be that it will be easier to cool down the temperature of the plant because it's straight on the ocean.
okay, thanks. Thank you. Anyone do have another opinion?
Jisok speaking. For me, one of the main advantages is probably the security factor, like as it was said before on the lecture. It can probably sustain an earthquake and a tsunami better than onshore nuclear power plant.
Okay, you say okay. Sorry. So I understand what you say is the capacity comparing onshore.
We cannot see your screen. Can you share your screen while you are typing?
Onshore. Right?
No, I was like it can sustain better against environmental weather conditions like earthquake and tsunami.
So your opinion is it is safer
Yeah, safer.
safer than onshore nuclear plant, right?
Yes.
Thank you. I agree with that. It is, I think, because it's on the ocean, so tsunami problem not care to offshore nuclear plant. So, other person to speak. Is there any person to speak opinions about this?
This is Amélie. I think a disadvantage is that you have to bring what has been produced back to the ground. So you have to, the travel distance is longer.
I'm sorry, I couldn't understand. Please speak slowly.
Since it is on the ocean, it is produced far away from the ground, so you have to bring it back.
You say it's movable?
Maybe I can help. Since the power plant is far from the shore, so you need to transfer the energy back to shore, and it's like the distance is far, and you need, for example, more cables, like longer cables to transfer the power from the plant itself to the shore.
Right?
Yes.
Thank you. Yeah, I agree with you. There is this disadvantage. And so I think it is far from the city, so there are some cost is high comparing onshore nuclear plant. I think there are some more advantage or disadvantage. So anybody to speak? I'm sorry.
No, I'm Dong Kim. But I think the advantage has the minimize the radiation exposure that is to people if the event have accident. Yeah, minimize the radiation exposure damage. Yeah.
Okay, I want to talk about disadvantage. My name is Gyuhyun. Maybe because it is floating, it is very vulnerable to the vibration of the tide or something. So it may needs a more stable platform because of the vibration. You have to design the vibration safe plants.
So you're saying it is unsafe because there are so many vibrations. So for example, reactor can have a fatigue failure like that?
Yes, such as that.
There are okay, always 5. So fatigue failure can occur. Right?
Yeah, similar.
Okay, thank you, your opinion. So I think I agree with you. So it is very hard to design the offshore nuclear power plant. So can offshore nuclear power plant be widely commercialized soon? Anybody have a opinion?
I'm Kabin Ryu, and I wanted to say something. So it's kind of, I agree with the previous opinion, but I think that it is possible for the power plant to be widely commercialized because like Kyuhyun talked about how there can be like vibrations or fatigue failure. But I also did some research and read that a lot of structures are being designed so that the natural period of like the structure itself is smaller than the wave period of, for example, a tide or a strong tsunami. And like the period can be larger than a peak storm wave period. So like these people at MIT are actually on the process of developing these like platforms with like minimized like oscillations. So based on this, I think if we like consider all these periods and oscillations and waves, it's possible to design a platform that's very successful and commercialized. Yeah.
Right? Is your opinion, right?
Yeah.
Very good summary.
Right? Like this?
Yeah, that's right.
Yep.
Okay, thank you your opinion. So, okay, is there anybody to speak opinion?
One last disadvantage I can see is like the cost of a nuclear plant. Like it's really expensive from the start, and if you want an offshore nuclear plant, it's going to be even more higher. So I don't think it can be widely commercial because of that. The cost is too much. Yeah, disadvantage. Disadvantage.
Oh yeah. Sorry. Yeah. Thank you your opinions. Okay. Let's move to second topics. I prepare second topics as a hydrogen production plant or base offshore wind power plant can be commercialized. At first, I introduce the advantage and disadvantage of offshore wind power plant. Offshore wind power plant is considered to be able to overcome the disadvantage of renewable energy, except one. Typical disadvantage of renewable energy is the first is capacity. Capacity is small. The second is space to install. Third is hard to control electricity generation. Capacity and space could overcome by offshore wind farms. If we use offshore wind power plant, a large size wind power generator can be installed over 5 megawatt. So if we made a farm, a group of generator, we can obtain large capacity of generator. But it is difficult to obtain the desired amount of electricity at the desired time by wind farm, because no wind, no generation. And the problem, electricity is very convenient for energy transfer, but it has a big problem. It's storing problem. Storing electricity is very difficult. In particular, the technology to store electricity for a long period of time and in a large capacity is not yet available. So it is needed to connect ESS system. ESS system is energy storage system. I will show you this figure. It's about energy storage systems. horizontal axis represents energy capacity. So high energy, low energy. Here is low energy, and the vertical axis means storage time. So here can store short time. Here can store a long period. So for renewable energy generation, so we need long high power and long time energy. We connect to high power and long period. Yes, it's same is hydrogen and pumped hydro. Pumped hydro can hydrogen is most suitable for storing large amount of electricity for a long period of time, because pumped hydro can also pumped hydro has limitation of space. It needs a mounting, so it is very hard to install. So we can say hydrogen and hydrogen can be obtained by electrolysis of water, including seawater. So some researcher present about offshore hydrogen production plant. At the left, Calcado and Castro present this paper last year. And in Korea, Korean Maritime Ocean University start research about hydrogen production ESS and renewable energy connected system. So the research is just started. So I think there are so many advantages, disadvantages, and expected problem and problems. So I want to listen your opinions about this system can be commercialized or not. So please tell me the opinion. Thank you.
I will start first. My name is Agateo, and I think one big advantage from this setup is that the ESS, I think, can be brought to shore, which can directly can reduce the cost of the cables needed, and also reduce the power wasted in the resistance of the cables that is needed to transfer the energy. Power dissipation. Yeah.
One more speak, please.
Power dissipation.
I do not know the spell. Power
Dissipation.
I'm sorry. I write in Korean. Please understand me. Yeah.
Yeah.
Yeah. So you say these opinions. You say it is a very good idea. Hydrogen power plant is a good idea to use a renewable energy system, right?
Yes.
Okay. So I show you something. This one is the building budget, construction budget. So it's over 5,000. I don't. It's very high. So my question is, this is can be commercialized. So it can be commercialized.
Well, based on the cost itself, I don't think it is it can be commercialized like easily, but like you can consider other advantages or other disadvantages, and like the advantage of having more like turbines, or like having greater out, like there might be a greater power generation from the turbine, like the turbines. So it can be a point to be considered if it's commercializable or not.
Everything.
Yes. Basically, we don't only consider like the cost itself, but how much also like the power generation and yeah, and everything else, the placement, yeah.
So is there anybody have an opinion?
Oh, can I say, yeah, thank you. I think it can also be commercialized because a lot of investments have like a large like initial amount of money you have to put input. But I read that actually like wind power is mostly being made onshore, but offshore we have higher speeds of wind, and actually the wind is more consistent in offshore environments. So I think the business will be very profitable in the long run. And also there might be some technical limitations, but you can, for example, add a fuel cell to like provide electricity for very high demand periods. So maybe we could use some technologies to control some frequency issues. So maybe, yeah, I think it can be commercialized in like the long run.
Right. So
I was not saying that like it's the most commercialized, but just that like offshore the wind is stronger and also the wind is more consistent. So it's better to have offshore wind systems than onshore. So in the long run, it will be very profitable.
So you say wind power is so good source to get energy. So any okay.
Mr. Lee, maybe we are quite over time.
Yeah.
We should wrap up the discussion session, I think.
Okay, thank you.
We are running out of time because there is another class. So we delay the teaming up next time on Thursday. Thank you for the discussion. Very nice.